In this video, I am going to explain about the design procedure for spur gear. So already we know the terminology used in gear. What are the M is mean by module. Z1, that is a 1 denotes a pinion, 2 denotes a gear, because we need a one is a driven shaft, another one is a driving shaft. One is a driving shaft, another one is a driven shaft. So power is transmitted from the driving to the driven shaft. Okay, so one is we need one pinion and one gear. So we use a notation, 1 denotes a pinion and 2 denotes a gear. So Z1 means number of teeth on pinion. Wherever we use the notation 1, that is meant by pinion. Wherever we use the notation 2, that is meant by gear. So M is a module, Z1 is the number of, Z is a number of teeth. If it's 1 means number of teeth on pinion. Z2, Z is the number of teeth. If it is a 2 means that is a number of teeth on gear. So N1, so 1 denotes a pinion and 2 denotes a gear. So N1 means, what is meant by N? Small n is the speed of the pinion in RPM, and N2 is the speed of the gear in RPM. I is the velocity ratio or speed ratio or transmission ratio, and alpha, we use alpha, that is because the gear are matting between the surfaces, so we need a pressure angle. So alpha we use always a 14.5 degree and 20 degree. Basically we use a 20 degree full depth involute. Then P equal to power, P or N, use a notation P or N equal to power in kilowatt, and F suffix T is a tangential tooth load in Newton, F suffix D is a dynamic tooth load in Newton, F suffix W is a wear load in Newton. So these are all the notations used. And sigma naught 1, that is a 1 indicates a pinion, 2 indicates a gear. Sigma naught 1 means that is a allowable static stress of the pinion in Newton per mm squared. Use a unit Newton per mm squared. And sigma naught 2 means that is a allowable static stress of gear in Newton per millimeter squared. Y is a Lewis form factor, A is the center distance, B is the face width, and P is a circular pitch. So these are all the notations used in the gear. First step 1, first we have to identify the weaker member. This is a step 1. First we identify the weaker member. Based on the weaker member, we have to design the gear. So step 1, how to identify the weaker member. So already we know what is that is a sigma naught. 1 indicates a pinion, 2 indicates a gear. So sigma naught 1 means that is a sigma naught is a allowable static stress. So we have to consider there is static stress. So stress values are given in table, new data handbook table 23.18. stress allowable static stress for different materials is given in your data handbook. Page number table number 23.18, they mention the allowable static stress for different material. So if you don't know the material is not given, you have to select the material. Based on the material, you have to take on the value from the table. That is a static allowable stress for a pinion and gear. After that, what is meant by Y? That is Y is a Lewis form factor. So sigma naught multiply by Y. You have to calculate sigma naught multiply by Y. What is meant by sigma naught? That is a allowable static stress. Y is the Lewis form factor. You have to multiply the two to get the value. Based on that, you have to identify the weaker member. For a pinion, you have to calculate the sigma naught 1 Y1, sigma naught 2 Y2. Which is a weaker, you have to select, and the design is based on the weaker member only. So what is meant by Y? It is a Lewis form factor. In the equation number, the formula for Lewis form factor finding the Y, the equation number in the data handbook 23.1152 to 23.117. In this equation, they given the formula to calculating the Y for the different types of involute system. Always we take if the pressure angle is not given, that is alpha is not given, you have to take a 20-degree full depth involute. Otherwise, if the alpha value is given 14 and a half degree means you have to select that equation. Based on that value, you have to select the equation. After that, you have to multiply the sigma naught 1 or sigma naught 2. Sigma naught 1 y1, sigma naught 2 y2. So, based on that, which is a lesser value, that is a weaker. If the pinion is weaker, you have to design based on the pinion. If the gear is weaker, you have to design based on the gear. This is the first step. Step 1 is identify the weaker member. Now, after identifying the weaker member, we move on the design. First step, so we have to calculate the transmit, that is a tangential tooth load. We have to calculate, there is a static load, dynamic load and wear load. First step, we have to calculate the static load, that is a tangential tooth load. So, we have the formula is given in your data handbook 23.87b. In new data handbook, the equation number is given for the tangential tooth load, that is a force analysis. Now, we can do the force analysis. So, after identifying the weaker member, we have to do the force analysis. First step, we have to analyze the static force, that is a tangential tooth load. The equation number is given in the new data handbook, equation number 23.87b. Formula is 9550 P into Cs divided by N into R. So, what is meant by P? That is a power. P denotes a power, C denotes a service factor, N is the speed and R is the radius. So, radius of the weaker member. So, if the design is based on the weaker member. So, power is given in your problem and service factor we have to take from the table 23.13. In the new data handbook, service factor value taken from the table 23.13 based on the duty, whether it is a shock load or heavy duty or light duty or medium duty, and number of hours per day also given, intermittent or 8 to 10 hours per day or 24 hours per day. In the tables the data are given. You take from the you take the service factor from the table, how to identify the CS. After that, N is the speed of the weaker member and R is the radius of the weaker member, P is the power. By substituting this value, we get the Ft, that is a tangential tooth load. After, you have to calculate the one more tangential tooth load based on the Levy's equation, because we have to finding the beam strength based on the Levy's equation. So, we compare these two, we have to calculate the module. Second step 1, you also calculate the tangential tooth load based on the Levy's equation. The formula is given in the equation number 23.131 or 23.132. The formula is given, Ft is equal to sigma naught. What is meant by sigma there? That is allowable static stress. B is the face width, Y is the Levy's form factor, P is the circular pitch, and Cv, that is a sigma naught Cv, that is a induced stress. Sigma Cv is the velocity factor. So, here we have to calculate the beam strength by using the Levy's equation. Cv is the velocity factor or dynamic factor. So, by using this formula, we have to calculate the another one tangential load. Compare these two equations, finding the module M by trial and error method. This is the step 1. So, based on the static load, we have to calculate the module of the teeth. After, next step, this is a step 2. First step is identify the weaker member. Next, you go to the design. Based on the static load, you design. Next, if the force is over, force analysis is over, you have to calculate the stress, check for a stress. So, that is the condition is induced stress. What is the formula for induced stress? That is allowable stress multiplied by velocity factor. That is a induced stress equal to allowable static stress sigma naught multiplied by Cv. So, what is meant by Cv? That is a velocity factor or dynamic factor. Formula is given from the Levy's equation. So, we have to calculate the induced stress, that is a sigma naught Cv. So for which the induced stress always lesser than the allowable stress, that is a design is satisfactory. Whenever we the induced stress always, we consider the induced stress always lesser than the allowable stress, then the design is satisfactory. This condition is satisfied, then move to the next step. The stress is satisfied, the condition is, the design is satisfactory. So after step 3, how to calculate the dimensions. After once you calculate the module, how to calculate the all other dimensions, that is a addendum, dedendum, circular pitch, all the values are given in the table. All the values are given in the, all the formulas are given in the table. And I explain later. Next step 4, after we have to calculate the check for the dynamic load. Once the static load is over, after you have to calculate the, you have to frame the dimensions, then we step 4, you have to calculate the dynamic load, endurance strength and wear load. This is a final step, the procedure for designing the spur gear.